Dear friends, now we are having Professor B. Shekhar ji. He is a senior professor in the Department of Management, University of Hyderabad. Today he is going to talk on data analysis using MS Excel. He is an acclaimed academician. He is having a lot of publications. His visibility on internet is also very high. He has been running a course, Swayam course also. Sir, you might not be knowing, I joined that course, I think some 2 years back, but I couldn't
Oh,
finish it because of some other engagements. I couldn't
okay.
go
No,
through
well,
also.
nice to know that, sir. Thank you.
Yeah, but I registered for that.
Okay,
That's
thank
good.
you.
So when I was organizing it, I thought better I call you for something on data analysis.
Sure. Thank you.
So, sir, this is a group of some 38 teachers from commerce, economics, and management.
Sir.
And we are having representatives from some 14 states. These participants are from 14 states, different states.
Okay.
Uh, from seven are from Maharashtra, some six are there from West Bengal. Tamil Nadu and Assam are having five each.
Okay.
From Mizoram, two are there.
Mm-hmm.
Karnataka, two.
Sir.
Uh, and some other states are one each from there, one or two is from there. Out
Sir.
of this group, some 15, 16, nearly half of them are PhD holders, and rest all of them are pursuing it.
Okay, sir.
Uh, Nearly half are from commerce background.
Okay.
And then second highest is economics, some 12, 13 are from economics, and some 4, 5 from management departments are there.
Okay, sir.
So, sir, now time is yours, sir. You can pick up from here.
Thank you, sir. Yeah, thank you very much. So, very good afternoon. Are you able to see the screen?
Yes, sir. Excel sheet we can see.
Yeah, Excel sheet only.
Okay, sir.
Fine, sir. I'll take care. Thank
Okay,
you.
sir. Okay, sir.
Thank you.
I'm
Thank you.
here only, sir. If you want, just call it. I will be here.
No problems. I will manage.
Okay.
So, yeah. Thank you, sir. So, very good afternoon. Am I audible, audience? Can you confirm me?
Yes, sir, you are audible.
But audience, can
Yeah,
they
yeah,
just,
audience, they don't have access to audio, so they are texting.
I think I'm looking at the chart.
Yeah, yes, they are mentioning, yes, sir.
Fine. Okay, sir. Thank you. Okay. So this is an Excel sheet. So in Excel sheet, we have rows and columns here, rows and columns, right? So if you are interested to know how many rows are there in Excel sheet, just you respond me in that chat box. Parallelly, I will be seeing the chat box also. Parallelly, I will be seeing the chat box. I would like to know from you how many rows are there in one Excel sheet. Any guess? Whatever number you feel, you type. At least one response I am looking for. About 10 lakhs. Okay. You are almost, yeah, this is the number. 10 lakh 48,576. 10 lakh 48,576. These are the number of rows. In the similar way, number of columns. 10 lakh 48,576. Okay. Number of columns. One more guess. Number of columns. Yes. Any guess? Number of columns in Excel sheet? At least one guess. 676. So let me show you. This is my last column. XFD. XFD. This is my last column. So XFD. XFD. Okay. XFD. XFD. So they are 16,384. 16,384. Total cells in one Excel sheet. These many cells are there in one Excel sheet. Approximately 1718 crore. 1718 crore. 1,718 crore. Is it clear? How to remember? How to remember this? You can see now. So how to remember this? This is equal to formula text. 2 power 20. 2 power, that is equal to 2 power 34. Is it clear? Is it clear now? At least I need one confirmation, because I cannot just go on speaking to you without your response. At least I need a chart response. 2 power 20. Yeah, 2 power 20. So approximately 1,718 crore. 1,718 crore. Okay. This is only in one sheet, and you have one more sheet. 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 You can see now how many sheets we can make. And this is only in one file. We can also think of, how many files we can make in Excel. So that is, that kind of a data we can handle in Excel. Okay. So this is one simple kind of a power of Excel I wanted to tell you. So this much kind of a data we can. Now, I wanted to use Excel for data analysis. Excel for data analysis. So there are several ways of looking at Excel, but I would like to concentrate more on data analysis tool. Excel as a data analysis tool. Okay. Excel is a data analysis tool. Okay. See, for example, some data. You're all from social sciences, commerce, management, economics, and so on. So we have some data. Let us take one variable. Let us take one variable, and I will show you how we are going to analyze the data with that variable. So you tell me you suggest me one variable of interest, one quantitative variable of interest. You suggest me one quantitative variable of interest. Yes. Okay. GDP. Investment. Okay. Then this is like this, let us have some kind of a height, age, weight. Okay. Height, age, weight, investment. Okay. Fine. So let us take some respondents here, because assuming that, we are conducting a survey. We are conducting a survey. So here, ID. I put ID. So let us take the sample size. So suggest me how much sample you wanted to take. I create the data set. Relationship between age and height. Okay, we will get back to that. So 1, 2. Yes. Okay. You tell me how much sample size you require. The sample size. 500. Okay, good. So I am now dragging up to 500. I am dragging up to 500. Yeah, this is my sample size. Okay, this is my sample. Okay, there are IDs. Okay, somebody said 750. I don't mind doing 750 also. So, okay, fine. So 750 sample you want? I do 750 also. So here probably what I do, there is a home. Here some series. The data is in rows. 1. Stop value is 750. Step value is 1. Oh, this is column. I should select column. Okay. Series. I want column. I want 750. Say okay. Now you can see control end. Yeah, I have 750 sample. Instead of dragging, I have used this option, fill the series. Since it is heading, I put in bold and red. Now here, I will have a variable of interest. Whatever you want, somebody say income, somebody say expenditure, somebody say investment, somebody can say savings, somebody can say debt, somebody can say height, age, weight, marks, cholesterol, fasting blood sugar, size of the family, height of the individual, weight of the individual, marks, aggregate, scored, CAT percentile, maybe GATE percentile, university examination scores, whatever, you can do it. Doesn't matter. Height, weight, age. Okay. So it could be anything. It could be anything. You can make some kind of a variable. So whatever variable you take, so let me say, let us go with the demographic data to begin with. Then I can go for some other data. Age. So I'm taking age. Okay. So I need to fill age of 750 people. How do I do that? How do I do that? How do I fill 750 students age, 750 respondents age? Yeah, I'm waiting for the response. Any guess how I should create dummy data for 750 people? Yes, questionnaire, of course, but here I'm saying in general. Yeah, that is outside, we collect the data through questionnaire. Yeah, so now I'm using a function called, rand between. Remember, rand between. See, age of the respondent varies from 20 to, say, for example, 60. That is what is my target age group. Okay, and I double click. Yeah, use random. Somebody said generating a random, yes, number. I have generated random number. So what is the function I have used? You can see now. Is equal to rand between 20 to 60. Is equal to rand between 20 to 60. Now I got age. You can see now control end. Yeah, we got the age for all 750 people. The only problem with this rand between function is if I do some operation here, the whole combination is changing. Whenever I am using this Excel sheet, doing something, typing something, so the data keep on changing. Now I wanted to make it fixed. How do I do that? Any guess? When you have this kind of a formula here, I don't want this formula to be there because that is highly dynamic. You can see now. Yeah. Copy and paste. Yeah. Copy, paste as special. paste as special. So now you can see if I click this, there is no formula. So if I type something, numbers are not changing. Numbers are not changing. Dollar symbol will be used later. I will tell you about that. That is locking the cell. So now this is what is the age of 750 people. So now I need to analyze the data. I need to analyze the data for 750 people. So tell me what all kinds of operations you require on this data. I have only one variable. Later I can bring one more variable, but right now I have only one variable, age. So some other variable I will bring in. But what kind of data analysis I can conduct on this variable? Mean, good. So somebody said mean. Yeah, mean is equal to average of, I select this column, 40.2387. I don't want these many decimals. I just keep 2. And you also said median. Median is equal to median. Select this column. And also let us go for mode. So is it clear now? Mean, median, mode, standard deviation, variance, skewness, kurtosis. For your understanding, I will write formula text. Formula text. Yeah, this is my formula. Somebody want, you can take photograph of it. Skewness, kurtosis. So this is what I have used. Mean, median, mode, standard deviation, variance, skewness, kurtosis. We have calculated 1, 2, 3, 4, 5, 6, 7. Okay. Anything else you want? Anything else you want? If you whatever you want, just you type. Yes, please. Skewness, kurtosis. chi-square. Yeah, chi-square we cannot do with one variable. So we require two variables. We require two variables that we will do little later. Chi-square we will do little later. But okay. Now, okay. Now what I am now trying to do, this may be little 10 percentile value. Okay, good. So quartile. Quartile. I wanted to know first quartile. Quartile 1 is equal to quartile array, comma, first quartile. This is first quartile. So first 25% of the items. Second quartile is nothing but median, 50%. So there is no need to calculate it. Third quartile is equal to quartile, this particular data set, comma, 3. This is quartile. So somebody said percentile. Mean deviation, quartile deviation. Okay. Quartile deviation. Mean deviation, quartile deviation. So quartile deviation cannot be calculated with the formula, directly with function. So you have to say Q3 minus Q1 by 2. Q3 minus Q1 by 2. 10. This is the quartile deviation. Then mean deviation, yeah, I'll come back. So mean deviation, I'll do that. There is no formula, but percentile. Percentile. So is equal to percentile. Percentile. Yeah. This is array. So you want 10%. 10 by 100. 0.1. So this is percentile 10. If you want percentile 20. Percentile 20. 20th percentile is equal to percentile this, comma, 0.2 percentile, 10 percentile, 20 percentile, whatever percentile you want. Say, for example, I want 25 percentile. I'll show you. 25 percentile is equal percentile B, comma, 0.25. 25%. 25 percentile is nothing but quartile 1. Because first quartile is also 25 percentile, right? So this, like this, whatever you want, you can calculate. So now we have set percentile also. Now somebody want to know mean deviation. Mean deviation. For mean deviation, the formula is mean deviation. This is mean deviation. X minus X bar. Okay. Mean deviation is equal to sigma X minus X minus X bar by N. X minus X bar by N. But we are putting mod, absolute. So let us see Let us see this. First, you have to calculate the mean. Mean is already with me. That is equal to, will the results be affected if there are missing values in Excel? I'll also show you. So this is equal to mean, age minus mean. This is the mean. F3, 14.76. But if I drag this, instead of mean, it has moved to F4. If I drag it further, it became F5. But actually, I want only F3. I want only F3. So that is where I'm using dollar symbol, F4. I press.
Sir, you are not audible.
Now, am I audible now?
Yes, yes, sir. Yes, sir. Yes.
Okay. So this is mean deviation. This is mean deviation. Okay. This is mean deviation. So what did I do now? Age, ID, assuming that this is some X. This is X minus mean. X minus mean. This is x minus mean. This is what I have done. X minus mean. Voice is not coming. Am I not audible now?
Audible, sir. You are audible, sir.
Somebody said voice is not coming. Rajesh. Yeah. So now x minus mean. So now, this is the mean deviation. So this is the sum. You can see sum of this entire column. So then divided by this. Okay. So somebody was asking about, missing values. Say, for example, now we can see, for example, this 55 is there. So let me take this data, copy. I paste here. This is my data. Okay. This is my data. So let me see average. Average. I'll just copy this. So 40.23867. This is my actual mean. Assuming that there is a blank. There is a blank. There is a blank. So automatically, when there is a missing value, you are getting a different answer. You can see now. These are missing values. These are missing values. So what exactly happening in this missing value business? If you wanted to take only 3 numbers, for example, here my mean is B1 to B2 to B5. I'm only taking 5 values. This is 48.75. This is the 48.75. But if you take one blank, it has become 46.66667, 66667. That means it has selected only this 4 and 48.667. B2 to B5. So what it is doing now, B2 to B5, if I take this 4, this is 46.75, but it is 46.66. So let us see the sum, how it is going to affect this. Sum of this 4, 187. 187 divided by, let us say, only 4 items. Only 4 items. 46.75. But if I keep 5, 37.5. Okay. By 4, 46.75. Here, average of B3 to B3, B2 to B6. Actually, 6 I have to keep. No? Yeah, 46.75. So what is happening now? It is only taking blank missing value, it is ignoring. So missing value, it is ignoring. It is only taking, though there are 5 items, but it is taking only average as 4. You can see here, average is only 4, the sum. So even if you have B2, 46.75, no change. So the same 46.75. So if the missing values are there, that will be just not taken into consideration. Is it clear now? Up to this point, if it is clear, I'll take the further, next level. Okay, great. So the first one is 55. Yeah, 55. I'll make it 55. So I take this data again, copy here. But somebody says, sir, in calculation of mean, median, mode, everything would be very complicated. I don't want to remember so many formulas. For which what I do, I go to data. There's something called data analysis. Data analysis. Data analysis. Click this. Click this. So once you click that, you see how many things we can do with MS Excel. How many things we can do with MS Excel. So here, we can do here ANOVA single factor, ANOVA two factor, with replication, without replication, correlation, covariance, descriptive statistics, exponential smoothing, F-test, then Fourier analysis, histogram, moving average, random number generation, rank and percentile, okay, rank and percentile, then regression, sampling, t-test, paired two sample, t-test, two sample assuming equal variance, t-test, two sample assuming unequal variance, z-test. These many things we can do. So let me select descriptive statistics. So here, input range, just select this column, labels in the first row, summary of statistics, and your output you wanted to have somewhere here. Just, or you can have a fresh sheet also. So you can see now all your descriptives have come here. Your mean is here. Your mean is here. Standard error is here. Median is here. And some standard deviation is here. Earlier, we have done with the different kinds of formulas. But now, straight away, median, mode, standard deviation, sample variance, kurtosis, skewness, range, minimum, maximum, sum, and count. These are the things we got. So whatever you have asked me, we got everything. Mean, standard error. So what did I do? I went to data. I went to data analysis, descriptive statistics. So input range, column B, heading in the first row, label in the first row, summary statistics, output I have given one cell reference. So I got this whole descriptive statistics at one go. Is it clear? Is it clear? Okay, fine. Yeah, good. So now let us see what is this variance, what is this standard deviation. Say for example, this is standard deviation multiplied by standard deviation square. You got variance. We got the same answer. 137.8535, 137.8535. We got same sample variance. Same sample variance. Okay? That is what, that means variance is equal to standard deviation into standard deviation. Standard deviation square. That is the logic. Sample variance is equal to product of standard deviation into standard deviation. Standard error is equal to standard deviation by square root of 750. 750. You can see now 4287245 So what we are saying here, this is draw, pen, this is standard deviation error. Is equal to sigma by, sigma is standard deviation, sigma by square root of n. That is the standard error. Standard error is equal to sigma by square root of n. That is standard error. That is where, we could get the same answer. And mean, standard error, median, mode, standard deviation, kurtosis, skewness, minima, maxima, range, sum, and count. Is it okay? Is it okay? Yes. Okay. Okay, fine. But still, you are finding it difficult. I think you need something better than this. So I'll type here. This is the data. You have, yeah, you have this data here. Simply, you select this column. You select this column. You could see here what is appearing. The average is appearing. Count 751, numerical count 750, minimum 20, maximum 60, sum 30,179. I did not do anything. I did not do anything. I simply mentioned, simply selected the column. Simply selected the column. I get whatever I wanted to see here. Are you able to see at the bottom here? The bar. Are you able to see average, count, numerical count, minimum, maximum? Are you able to see this? Yes or no? Are you able to see this at the bottom? Yes, 220. Yeah. So that now if I select the second column, this column's minimum maximum is coming. Minimum 1, maximum 750, sum is given, number of count is given, numerical count is given, average is given. You can see. Simply you have to select the column. Simply you have to select the column. Once you select the column, you get this output. Is it okay? Is it interesting? Is it interesting? I have taken only one variable so far. I didn't do much. Taken only one variable. The one variable only we have been doing all this. Okay. Now, I am introducing one more variable here, gender. Usually in our social science research, so we have to put the gender variable. Gender variable. So when we wanted to have gender variable here, gender variable. Now, how do we fill 750 genders? How do we fill 750 genders? Any idea? Dummy variable. Okay, good. So I'll say rand between 0, 1. That's what is the meaning of dummy variable. So what is 1? Is a 0 male, 1 female. Okay. Why not reverse? Why not reverse? Why not 0 female, 1 male? Why we should take 0 male, 1 female? Why not reverse? Why not reverse? Yes, please. Gender bias. Usually what we can say, reverse can also be taken, but usually what happens is alphabetically female comes before male. So 0 comes before 1. So this is how we should code. Female 0, male 1, because alphabetically F comes before M, 0 comes before 1. So that is the sequence. So for example, if I wanted to give 1 and 2, this is how we should give 1 and 2. Or I wanted to do some kind of a Hyderabad, Chennai, Hyderabad, Chennai, Delhi, Bangalore. If I wanted to code them, how should I code? First B, 1, C, 2, D, 3. That is some kind of a pattern. The sequence we should follow. 1, 2, 3, 4. 1, 2, 3, 4. Okay? This is how we should be doing it. But again, the same problem. And one more advantage of taking 1 and 0. So now I told you 1 is male, 0 is female. 1 is male, 0 is female. So one advantage of this coding is if I select this column, you see the total. Total is how much? 367. That means there are 367 male, remaining are female. There are 367 male. So you need not, for example, if I keep 1, 2, 3, 1, 1, 2, 1, 2, 1, 2, it will be very difficult for me to count how many males are there, how many females are there. But here, it is easy for you to just count, select this. It's not only for this, satisfied, not satisfied, 1, 0. Smoker, non-smoker, 1, 0. Alcoholic, non-alcoholic, 1, 0. Satisfied, not satisfied, 1, 0. Promoted, not promoted, 1, 0. Passed, failed, 1, 0. So this always it would be advantage that, simply by putting a cursor here, you will come to know how many ones are there, how many zeros are there. Is it okay? Is it clear? Yeah. Okay. Fine. Fine. Okay. Okay. No, this is it. But the problem is again, if I click here, again this rand between is there. To avoid that problem, to avoid this problem, copy, paste as values. Paste as values. So that if I double click this, there is no formula. If I double click this, there is no formula. So if I take the total, it is 375. 750 is male. 375, 750 is total sample. 375 male and 375 female. But I wanted to, this is exactly 50-50. But I wanted to make it 40-60. 40-60. So I wanted to have 60% female, 40% male. Just I am doing some kind of a manipulation. Some kind of a manipulation I am doing. Now you can see 264. So my target is 750 and 264. 264 is equal. I'm doing just manipulation for the 1/3 and 2/3, something like that I wanted to have. 1/3, 2/3. Yeah, just 264. So my target is I wanted to have 250 female and 250 or maybe 60%. 60% of 750. 0.6, let me see. 450. 450 and 300. Okay, 450 and 300. So just I am now trying to see that. I'm trying to see that 450, so, and 300. So I would like to have, so if you see here, sum is 300, ones are 300s. You can see now. So now I have made the data in such a way that if I click this, sum 300, that means there are 300 ones. There are 300 ones. So otherwise, I can also use a function called count if. Count if. This is the range. I'm counting for 1, 300. I'm counting for 0, 450. So this is what I wanted to have. So now I can say 0 means female, I said, no? So this is female. Female. This is male. Male is 300. Okay. So this is my sample. We have 300 male, 450 female. So this is how I have manipulated the data. At this point in time, again, I would like to know from you what kind of operations you can give if you are given this gender. Now you are having gender and say X, marks, height, weight, age, whatever. Whatever you want, you can. So what do you say? You tell me now. Just I would like to hear from you what else we can do. Earlier I had only one variable X, that is a continuous variable. Now I have categorical variable, that is gender. That is gender. So gender and X is given. Now I would like to know what kind of analysis you would like to do. Now there are two variables. Gender is one variable, X is another variable, whatever you name. With these two variables, what kind of analysis I can do? Yes, please. At least one or two responses. When you are given gender and one variable of interest, what do you want to do? At least one response, if not two. Please type. You are given gender and one variable of interest. Okay, chi-square test. Chi-square test. Okay, male and female. But the chi-square test, when you do the cross tabulation, I think I require one more variable. So male, female, and gender. Because I should be mean difference by gender. Okay, mean difference by gender. That is one. And the chi-square test. For ANOVA, we cannot do because ANOVA require more than two samples. So, but t-test we can do, right? T-test we can do. If you wanted to do chi-square, the problem is, I need to do some kind of a cross tabulation. So I will have gender. Then here also I would like to have one more category. Then only I can do that. Okay, let me try what kind of things I can do. So I'll show you one after other. One after other. Okay. So this is ID, gender. and X. Okay, ID, gender, and X. So we have variable X and gender and ID. Okay. So now the chi-square is a problem because we don't have another variable. Paired t-test we cannot do. Independent t-test we can do because paired t-test we will do when we have before and after. Before and after. But here, what I would like to do. So now I have a gender variable. So I select this data. I select this data. Then I select this data. Then I select this data. Come to yeah. This is sort filter. I'm using a function called filter. So I delete 0. I put only 0. I put only 0. So all my female got separated. And if you select this, I will see average age of female is here. Count is here. Numerical count is here. Minimum is here. Maximum is here. Sum is here. And if you come here and select only one, that is for male. So total 300, minimum, maximum, average is 41.44. 41.44. This is how we can use a simple function called filter. I'm using a function called filter. By using function called filter, I can separate them. Say, for example, I have this data, copy, paste here. So all female data is pasted here. All male data, sorry. If I select this, yeah. Now I have segregated male and female data. So this is 1, means it is male. And this is female. I have separated these two, male and female. So this is 1, this is 1. I am now taking two samples, two independent samples, male and female, male and female. So male and female samples are here. Up to this, it is clear? Is it clear up to now? Yes. Okay. Fine. Okay. Here, how I have pasted. Just, I selected this one column, control, second column, control and select. Then come here and paste both. So they will be pasted side by side. So this is male and female. So here somebody was asking about, independent t-test. So here I have a null hypothesis. Null hypothesis. H naught. H naught. Mu1 is equal to mu2. Mu1 is equal to mu2. H naught, and we are going for mu1 is equal to mu2. So H1 is mu1 is not equal to mu2. This is my null hypothesis and alternate hypothesis. And alpha is equal to 0.05. This is level of significance. So H naught mu1 is equal to mu2, and h1 mu1 is not equal to mu2, alpha 0.05, 0.05 alpha. Then I am supposed to test whether these two population means are equal or not. They are equal or not. Okay, they are equal or not. Okay, for which null hypothesis says mu1 is equal to mu2, mu1 is equal to mu2. Yeah, mu1 is equal to mu2. And h1 is mu1 is not equal to mu2. Alpha is equal to 0.05. Now I have to use t-test, independent sample t-test. Go to data, and here data analysis. In data analysis, we have t-test not paid. Two sample assuming equal variances, assuming unequal variances. So I am assuming unequal variances. Why I am assuming unequal variances? If you want, I can calculate the variance of first sample. We'll see how it happens. Variance of the first sample. I am just showing this is the variance 1. That means first sample. Then I say variance 2 is equal to variance of the this 130, 141. So this is for sample, assuming that this is for sample. So when you extrapolate to population, this difference of 10 may not be that significant. Even if you assume they are of equal also, fine. So let us see both equal and unequal. So data analysis, go for t-test, assuming equal variances. This is variable 1, this is variable 2. Labels in the first row, alpha is equal to 0.05. This is your output range. Yeah. So you can see now t-test. This mean is 41, this is 39. Whether this is sample means, whether the sample says, there is almost like a 2 difference. 39 and 41, there is a difference of 2, like this. 2, 130, 141, 300, 450, hypothesis is the mean. Look at the p-value. P-value. And 2 times 0.02. So here it is less than 0.05. Less than. So why should I consider p-value, p for probability? Why it is a two-tail we should consider? Because my alternate hypothesis I said not equal to. If I say less than or greater than symbol in alternate hypothesis, I have to go for one-tail test. If it is less than or greater than in the alternate hypothesis, I may go for one-tail test. But if I say inequality, then I have to go for here. You have to go for two-tail test. In both the cases, 0.05 is 0.01 is less than 0.05. So what I am now saying, reject null hypothesis. Reject null hypothesis. Reject null hypothesis. Reject null hypothesis. That means mu1 is not equal to mu2. The population mean. Repeat how you have pasted. It is possible to have equal variances to all the groups. Please repeat one-tail test. Okay. possible to have equal variances of all the groups. It may be possible, it may not be possible, but in this case, the variance is 130, 141. I will also make a comparison also, assuming equal variances. So let us also look at something unequal variances and we will see the result. That's not a problem. So here, here we will see this is one. The second one, for example, go to data. Yeah, one tile, two tile. Your alternate hypothesis you have to see. It is not equal to. It is not equal to. So then two tile. Two tile. Less than or greater than. You are testing A and B, you are comparing. Whether A is better than B, B is better than A. You are saying, then it is one tile. A is not equal to B. That is two tile. Not equal to is two tile. Less than or greater than is one tile. Less than greater than is one tile. So now let us do the same problem with unequal variances. Unequal variances. So data analysis, unequal variances. So input range is first, second, labels in the first row, labels in the first row. Okay. So here output range somewhere around here I will put. Assuming unequal output will overwrite existing data. Cancel. So maybe it's a new worksheet. Okay, let me say new worksheet. So this is my data. So I wanted to make a comparison of sheet 12. Yeah. Okay. Sheet 12. So now you can compare 41.144, no change. 130, 141, no change. 300, 450, no change. Here there is something called pooled variance is computed. Degrees of freedom, okay. Degrees of freedom, okay. So this is 0.011, 0.022. So if you want to make it only two decimals, you can make a better comparison. Yeah. So here also, if you make a two decimals, okay. So 0.01, 0.01, 0.02, 0.02. One more if you want to have. Yes. Yeah. 0.011, 0.0011, 0.022, 0. Not much difference between these two. So in both the cases, null hypothesis is rejected. That means the population means are not same. Based on the sample means, we are trying to make the estimation or judgment about the population. So what we say is both the population means are not same. Is it clear? Yes, please. Is it okay? Is it okay? Yes. 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 Okay. So now sheet 8, sheet 9. Why one-tailed test has been considered here? Why not two-tailed test? When is rejected null hypothesis? See, you look at our alternate hypothesis, male and female. The male population mean is more than female population. Female population mean is more than male population. One is when you are using less than or greater than in alternate hypothesis, you have rejection zone one side only. When you say it is not both sides, that means less than or unequal to. When you say unequal to, not equal to, then your this rejection zone is two sides. So for you to understand that, I'll do one thing quickly. Quickly, I'll do one thing. I take normal curve. Yeah, let us take normal curve. Normal curve. Normal curve. Let me take one normal curve image. Are you able to see this paint screen? Are you able to see the paint screen? Okay, good. So this is the normal curve. So when you are saying the rejection zone one side, so less than or greater than, for example, less than or greater than. So we can say, for example, rejection zone. So this is a one-tailed test. Rejection only one side. So entire level of significance, you cannot see Ashok Sharma. You can't see. Okay. Share. Okay. Now are you able to see the normal distribution curve? Bell-shaped curve, yes. So entire 5% of, see, for example, this whole is called 100%. It is all 100%. Area under the normal curve is 100%. But if I keep 5%, this is rejection zone. The remaining is non-rejection zone. So this is when you have A is less than B. But sometimes what happens, you just to take this. So entire 5%, A is more than B. We are testing A is more than B. So this is called right tail test. The earlier one is called left tail test. This is called right tail test. Right tail test. The earlier one is yeah. If I select these two, it is a two-tail test. It is a two-tail test. The two-tail test means it could be less than, it could be greater than. So when I'm comparing A and B, null hypothesis says A and B are same. Alternate hypothesis says A is less than B, or A is greater than B, or A is not equal to B. If A is less than B, it is a left tail test. Only one rejection. It will not be there. So if it is A is greater than B, then right tail test, only rejection 5% is here. But if I say A is not equal to B, then alpha by 2, level of significance by 2, and the level of significance by 2. Level of significance by 2, level of significance by 2. So this particular thing, this is a two-tail test. So if you look at the table value, so here, whatever we had, the two-tail test, we have 5%, say for example, 5%. So if it is 5%, so 5%, you are saying this is this particular thing is 2.5%. This part is 2.5%. And this part is again 2.5%. 5%, 2.5%, 2.5%. So what is this critical value of 2.5%? The normal table, the critical value is 1.96, 1.96. Here minus 1.96. And this is plus 1.96. These are the values. 1.96 plus 1.96 minus 1.96. These are the two values. But your calculated value is t value is a 2.29. T value is 2.29. So this is 1.96 minus 1.96 plus 1.96. So my t value from the Excel sheet, whatever I have calculated, is 2.29. So 2.29 is 1.96. No, somewhere here I'll have 2.29. 2.29. So this 2.29 is falling in rejection region. So reject null hypothesis. Reject null hypothesis. So that is the logic. So 2.29 is the t value. This is nothing but a t. This is small t. This is a t is equal to 2.29. So 2.29 is falling in rejection region. So reject null hypothesis. Is it clear? Okay. Is it clear now? How we are taking the decision. That is how we take. But otherwise, simply you can go by your Excel sheet. This is the t value, 2.29. Otherwise, you can look at only p values. If it is less than 0.05, reject null hypothesis. Otherwise, don't reject null hypothesis. This is the simple thing. Okay. Now, we will also do something more. I take this data. This is gender, male, female. So here, again, I wanted to get back my data. Filter. Yeah. If I remove filter, so this is my data. Gender, X, whatever. So select these three, go to insert pivot table. Say you can say like this. Pivot table. In this pivot table, you can have gender here. This ID you can bring here. But if you see, the total is supposed to be 750, but you are getting more. So for reason is here, sum of IDs mentioned here. Click here, value field settings. You say change it to count. So this is how 0, 150. The advantage of this is, if you double click this, so you get this particular sheet open. In the similar way, if I double click this, you get another sheet open, female sheet. So this is how this is the advantages. So we have 0, 1, then cross tabulation. If you wanted to say cross tabulation, for which what I am going to do now. Sheet 13, sheet 7. Yeah. So here I would like to say employment status. Employment. Employed, not employed. Employed, not employed. This is how I'm trying to look into that. Is equal to rand between 0, 1. Okay. Yeah. Copy, paste as values. Okay, sorry. Now the rand function is gone. Now I would like to say here, find replace here. You select this. Find and replace. Find and replace. Where is it? Yeah, find and replace. Replace 0, 0 with the female. Replace all. 450. 1 with male. Yes, done. Now I select these two. Replace 0. 0 is unemployed. So you can ask me unemployed, employed. Employed comes later. But why I am putting here is I am interested more about employment. That is where I am putting employment 1, unemployment 0. Replace all. Okay. So I say 1 here. It is employed. Now you could see that data now. So gender, employment, unemployment. Just here I'm putting this age. Yeah, just like that, I said it. Now I select all, insert pivot table. So here I say yeah. Here I'll say gender here. Gender. Employment here. ID numbers here. Instead of sum, field settings, say count. So this is how we have cross-tabulated. Now I wanted to test the hypothesis whether gender of the respondent and employment status of the respondent, they are dependent or independent. They are dependent or independent. So if they are dependent or independent. If they are independent, null hypothesis says they are independent. Alternate hypothesis says they are dependent. Null hypothesis says these two are independent. So that means, so somebody's employment status is independent of gender. The alternate hypothesis says somebody's employment status is dependent of the gender. So then for which kind of this kind of a cross tabulated data, we are going to use the chi-square. We are going to use chi-square. So for which, there's a formula, but there's no straight way of doing chi-square in Excel. So here we have to calculate observed values, expected values. I think, these are called observed values. Observed values. So what are observed values? 231, 219, 159, 141. So these are observed values. Observed values. So I need to calculate expected values. Expected values. So expected values, how do we compute? The corresponding row total, first one, for example, corresponding column total by grand total. In the similar way, corresponding row total for 219, corresponding column total by grand total. Okay. In the similar way, corresponding row total into corresponding column total divided by grand total. In the similar way, corresponding row total into corresponding column total by grand total. Interestingly, if you take the sum, you get 750. If you drag this, 750. Now chi-square value is equal to chi-square is equal to chi-square. Chi-square test. Actual range, observed values, 4. Expected range. So this is observed values and expected values. So it is more than 0.05. More than 0.05. So the conclusion is do not reject null hypothesis. So they are independent. There is no, if it is p-value is less than 0.05, then you have to reject null hypothesis. You say there is a dependency. But in this case, there is no dependency. That is how you are going to compute. Okay. If more than two samples are there, then we go for ANOVA. So more than two samples are there, we go for ANOVA. So this is how we are going to make the analysis. So just I wanted to give you some kind of a introduction to data analysis using Excel. So with this, I'll stop here. If you have any specific questions, you can ask me. Otherwise, we'll stop. Yes, please. Is it okay?
Participants, is there any question? Because, sir, there is no question at question answer box.
Yes, a chat box, no questions. Everything is
Yes.
done.
So you have already taken care of all the questions, whatever came in the process.
Yes.
Yeah, sure.
But still, if anyone is having any question, we may take 1 or 2 more minutes. So someone is asking for the last Excel sheet.
No, this Excel sheet they wanted to be shared, I will share.
Yeah. So you can send it to me and I can share in the group.
Sure. Yeah.
So anyone else is having any question? I think nothing is there, sir.
Okay, sir. Yeah. If nothing is there, I'll stop here. Thank you very much.
Okay.
Yeah.
Sir, someone is asking Excel analysis is okay for PhD thesis. So there is no problem in anything. We need results. Whatever tool we use, no problem.
But lot of customization we have to do in Excel. We may not get very straight like, SPSS or Jamovi. I think basic analysis we can do, but advanced analysis, we may have to do lot of pre-processing, lot of adjustment of the data.
Mhm.
That's not very straightforward kind of a outcome, but it is more, will give you understanding of this. But basic things we can do. But certain things we cannot do like factor analysis, cluster analysis, conjoint analysis.
Mhm.
For example, chi-square, we may have to do manually. T-test also, a single sample T-test we have to do manually. Certain things, there are some limitations. Yeah.
Yeah, so some limitations are there, but yeah, it will be an helpful thing for
Yeah,
you.
definitely.
But
Definitely, I think in the classroom, I think, research methodology teaching, statistics teaching, I think we can use very extensively.
okay, okay.
Yeah.
So I think so there is no more questions, so we can end this session here. And thanks for a very detailed demonstration of statistical analysis using MS Excel. So thank you
Thank
for
you,
that,
sir.
sir.
Thank you, sir.
Thank you, sir.
Thank you. Thank you. All the best. See you.
Uh-huh.
Bye bye.
Bye-bye, sir.